how much energy is it going to take to move my electron to the 55 volt mark from the 45? How much energy would it take to move my electron out to the 65 volt mark? Okay, pretty simple plug and chug problem. Right. The equation I want to use here is work equals charge times potential difference, the change in potential here. W equals Q delta V. You okay now? Now work is the same thing as what? Energy. So I'm asking how much energy is the same thing as me asking how much work must you do, right? How much energy does it take to do that? It's the same thing as how much work must you do. So work equals, what is the charge of an electron, somebody? Yeah, guess where you can get it from? Packet. Pull it out. It is the elementary charge. Now, to get the first one, to go from 45 to 55, what is the potential difference? 10 volts, right? So, 10. Work equals what? Yeah, 1.6 times 10 to the negative 18 joules. A really small amount because I'm just moving an electron. One single small electron. We're going to get back to the electron volt here in a little bit. So this is kind of a predecessor to that. Okay, just a very small amount. Now, in the next one, right? If I want to go 65, well, work equals Q delta V. Work equals the charge of an electron, 1.6 times 10 to the negative 19th times. What's the potential difference to get out to the 65? Yeah, from 45. 20. Woo! All right. And so then you plug into your calculator, right? Actually, you plug into your calculator 2 times the 1.6. So we got, right? By the way, what is 2 times 1.6? 3.2. Good. Okay. And those are the simple plug check problems you do with that. Nice and easy. Let me talk about charge for a second, because I haven't addressed this with the electron. Charge is quantized. Charge is quantized. What do I mean by charge is quantized? What does quantized mean? Have you talked about this? Quantum?
Well, it means that it has the smallest unit.
Yes. Bingo. Yeah. It has a smallest unit. There is no in between. Okay. It has a smallest unit, and there is no in between. Charge is quantized. It's quantized by the charge of the electron, which is the negative, and the charge of the proton, same amount, just positive. Okay? You can't have a half electron. Not possible. You can't have a quarter of an electron. What do? Get out your knife and cut it in half? You know? You're not doing it. Okay? You don't have halves and fourths of electrons. All charge is quantized. Everything is multiples of the charge of the electrons. 2 electrons, 9 electrons, 10 electrons, 5 moles of electrons, whatever.
That's a kind of charge. Why would they randomly pick a number of the
Historical reasons from before really we knew about the charge of the electron. But because we knew about electricity well before we knew about electrons. And there's going to be some other very confusing things with that too. For example, we're going to make our positive charge move through the wires of the negatives. But we'll get to that. Again, look. Yeah, it's exactly what the taser does. It's putting out a current, right? So that shock that was coming out in my hand, it's current flowing. Current is what flows through my nerve, that electrical flow called current, right? To make your muscles contract. Well, if a taser hits you, it's putting in way more current than your brain puts out. By the way, your brain puts out a very low grade current, right? Through the nerves to your muscles. So if they're getting it with a very powerful one, just like if you stuck your fingers in the wall outlet, okay, more currents going through your body at that point in time from the wall outlet, from the taser gun, from whatever, that's telling all of your muscles to contract, then your brain's little amount of current Does that make sense? Your brain can say whatever it wants. It's like going to, a car shop or wherever, turning the music all the way up at a loud concert, okay, where it's insanely loud, and you're going to stand up and yell. If you're at a very loud concert, big place, and you're on one side, and your friend's on the other side, you can yell at your friend all you want. He ain't hearing you, okay? Same thing as it comes to with tasers and sticking your fingers in the wall. The electrical current is so much greater than what your brain's able to put out. Your brain cannot control the muscles anymore. Okay, it's been overruled.